wabarakatuh. My name is Nur Binti AZMAN, DE190068, and this is my group member, Muhammad SAFII, name Muhammad Saleh, DE190048, and then Dayana binti Yusri, AE190111, and last, SYAMIL BAKRI bin IBRAHIM, CE19010170. We are from Group 8. I will explain the introduction of our project. Digital audio filtering is a linear system that changes the amplitude or phase or one or more frequency component of an audio signal, which is one of the main operations in digital signal processing. Digital signal processing has a property to manipulate the information signal and modify or improve in some manner that the signal characteristic has to be changed. There are two fundamental types of digital filter, which is finite impulse response and then infinite impulse response. These filters are depends upon their impulse response. The filter can be defined as the filter whose impulse response is one finite period. And then I filter is a digital filter which is infinite impulse response. Unlike field filter, they have the feedback and are known as recursive digital filter. Therefore, lastly, for this reason, IIR filter have much better frequency response than field filter. In this project assignment, we as a group need to analyze an unknown signal time domain is more significant, where the state response is one of the important parameters. In the frequency domain, the filtering operation involves the multiplication of the Fourier transform of the input and the Fourier transform of the impulse response. I will explain the literature review in this project. First of all, in the digital signal processing DSP, digital data can be sent on carrier through phase, frequency, and amplitude. Besides that, the digital filter, which is one of the main operations in digital signal processing, is a mathematical algorithm that operates on a digital dataset in order to extract information of interest and remove any unwanted information. Field filter is filter whose impulse respond or respond to any finite length input. After that, the response is infinite because there is feedback in. There are difference between field filter and IR filter. In this project assignment, we have to design boards of the filter which is include the finite impulse response and infinite impulse response to filter the given signal and represent it in the Z domain using the MATLAB software. That's all from me. Thank you.
Hello, Assalamualaikum. My name is SYAMIL bin IBRAHIM. My metric card is CE190170. So today I would like to explain about this problem statement, objective of the project, and the methodology. So first of all, I'm going to explain for the problem statement. So as you know, for the point 1, which is FIR and IIR filter created to solve the issue of signal loss or degradation of sound or picture quality. Number 2, frequency modulation, transmission and reception equipment is complicated and expensive. So number 3 is decreases the original signal's quality at the receiving end and has negative effect on the signal quality when it comes to us. So this is the problem that we can get from our project, which is the signal processing. So for the objective of the project is to design appropriate finite impulse response (FIR) and infinite impulse response (IIR) filters for denoising the given audio signal using the MATLAB software. So for the first objective is we do this project with using the MATLAB software. So the objective number 2 is to analyze and simulate the filtering of the signal using IIR and FIR band pass filters, as well as how the use of filters in digital signal system can be advantageous. So number 3 is to researching and comprehending the discrete Fourier transform technique in representation of the audio signal in frequency response, and to comprehend the analyzed Z transform technique in representation of the digital filters. So I will continue to the methodology, We must first use the convolution approach to determine a system output signal in order to find the solution. The signal must first be represented in frequency domain using discrete Fourier transform technique before we can visualize it. The discrete time signal, which is made up of a series of real or complex values, is when transformed using the Z transform into a complex frequency domain, also known as Z domain or Z plane representation. So the methodology of this project is we using the discrete Fourier transform technique before we can visualize it. So we can get the output from this discrete Fourier transform using the magnet software. So that's all from my part. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad SAFII bin Muhammad Saleh. My metric number is DE19004. Okay, so today I'll be presenting for the simulation for the DSP project. So here I will present for the FIR filter. Okay, so here I divide into three sections for the code. So for the first section here is the coding where we will run the this signal, which is we get from the original source signal that we received from the lecturer before constructing this code. So then from the signal we will generate a graph which contains the signal of this file. So later it will produce a music sound with unnecessary noise interference. So for the second section here, we have designed the discrete Fourier transform technique, and the last section here is where we construct the FIR filter design. So here is the equation that we need to declare for designing the FIR filter. And here we have chosen the low pass filter, which use the Chebyshev window. And then here, when we run, it will generate a graph of the low pass filter. And here it will generate the origin signal back. And here it will generate the filter signal. So it will reduce the noise interference of the song. Okay, so we will demonstrate one by one for the coding. So let's start with this section first. So as we can see in the first section here, we can hear a song, but the song is played with an unfiltered, unnecessary noise interference. So next I will run this section. So here it will generate graphic signal. So the signal is from the first source over here, and it will show the magnetic spectrum and the phase spectrum here. So lastly, we will run the section, which is it will filter the first source signal here, and we will hear the song a little bit more clearly with the reduction of the noise. So as we can hear earlier, the song is has filtered the unnecessary noise that we don't want to hear, so the song has more clarity and more fine sound to be heard. So here is the graph for the low pass filter that we use. And so here it will generate back the original signal. Here is the graph for the filter signal, which then will give the sound the clearer which we have heard the song with more clear and more clarity of the music and the lyrics. Okay, so that is all for the presentation for the FIR filter signal. Thank you. Okay, Assalamualaikum warahmatullahi wabarakatuh. So I will be continuing the presentation for the IIR filter. So this is the first section. So for this section here, we have the data for the Excel which I have declared here, and this is the equation for the sampling rate and FS, TS. Here is the Fourier transform, and this is the plot for the graph for the source signal. Move on to the next section. Here we have the IR filter design. So FC is the cutoff frequency, which we will get the value from this section, which we will run later. LFS, and then here is the necessary filter design code. So here we need to adjust the value of the lib, the N, RPRS, and window. Then I'm done. GTF to line 8, and from this line here is the Z transform code, and all the way down here is the code for the output graph for the filter signal. Here we will get the sound. So we will see simulation. So here is the graph for the first section, the code. So next, for the IR filter design for the cutoff frequency over here, we will use this value over here, which is the X value is 7699.83. So that is the value that I've set earlier that we will use in this filter design. Then I will run this section. It will take a little bit more time to run for the IR filter design, so we will wait. Okay, so this is the magnitude response graph for the IIR filter design. So here we can see the filtered signal of the IIR filter. So this is the phase spectrum of the filtering. So compared to the first signal, source signal, so the IIR filter have filtered the signal, but there is some noises that a little bit of noises that it can be filtered, so the filter cannot filter the signal properly, completely, and so that is the result for the IIR filter. So it is not as perfect as the output signal as the FIR filter. So the IIR filter, maybe we need to adjust more the value of the filter. So that is all from me. Thank you.
Hi, Assalamualaikum. My name is BINTI Yusri. My metric number is 8810111. So now it's my turn to conclude for the whole project. So in this project, we have compared and analyzed the simulation result between finite impulse responses and infinite impulse responses filters using MATLAB simulator through the difference in the amplitude, convolution, and phase spectrum to achieve the nearest ideal filter responses. So once the comparison is made, we can see here that the finite impulse response filters generate finite impulse responses of a dynamic system because it is settles to zero infinite time, while the infinite impulse response filters generate infinite impulse responses of a dynamic system from continuous time filters, in which the impulse response of the continuous time system is sampled to produce the impulse response of the discrete time system. Through this project also has given us knowledge about digital signal processing for the whole techniques indirectly. A convolution is a mathematical tool to combine two signals to form a third signal. Therefore, convolution is very important in signals and system because it relates the input signal and the system impulse response to produce the system output signal. So in this project, we have observed from the result and analysis which finite impulse responses always stable, and the stability is more than that infinite impulse responses filter due to the presence of poles, which filter finite impulse responses do not contain any poles, which we can see here from the results part. The finite impulse responses and infinite impulse responses filters also are a very important part of digital signal processing. According to the modes of operation and output needed, the filters can be used easily. These digital filters are designed in various computer software programs, and the filters work with the frequency transformation of the system in both the analog and digital domains. So that's all from us. Thank you.